This is part of a series of demonstration videos to review how openstack-helm works. openstack-helm is an open source project that aims to provide a fully self-contained Helm-based OpenStack deployment on top of Kubernetes. In this particular video, I'm going to demonstrate a hitless upgrade of the OpenStack cinder component. I'm going to take the component from a mitaka release to a Newton release, and we're going to go ahead and create a test volume to ensure that that resource, of course, comes along for the ride. On top of that, we want to demonstrate some of the resiliency features that are baked into most of the OpenStack Helm charts, and also demonstrate some Kubernetes resiliency features by showing that during the upgrade process, we do not take the Cinder API offline for this transition to occur. So as an end user of this OpenStack cloud that's running on top of Kubernetes, I want to be able to see that during the entire upgrade process, I am able to talk to the Cinder API. So the very first thing that we're going to do is verify that we can actually talk to the Cinder API that's actually running, that was deployed using OpenStack Helm. The next thing that we want to do is make sure that we create a test volume. We're just going to create one of 1 gigabyte in size to make sure that we have an artifact inside Cinder that will actually come along for the ride. Now, OpenStack Helm deploys Cinder by default leveraging an RBD Ceph backend because OpenStack Helm contains a fully functioning Ceph chart. So that backend storage is already there and able to be leveraged. So at this point, our volume should be available. It was provisioned on Ceph, which is running in our control plane as part of OpenStack Helm. And what we want to do now is go ahead and set up a little simple loop to make sure that we can poll the Cinder API the entire time while we are doing the actual rolling upgrade from mitaka to Newton. So to validate that we're actually running the mitaka version of Cinder, we need to dip inside the containers that are running our Cinder API and just validate what git commit those containers are actually at. So this small little shell script just executes inside the context of one of these containers and grabs the git log from /cinder. And what we see here is that this is the commit ID that we're at, beginning with F33, and it was this git commit was committed in August. So F33 is roundabout close enough to mitaka. Those familiar might recognize that this is not the precise commit from the mitaka tag, but it is close enough to demonstrate an upgrade. So the next thing we're going to do is actually launch the upgrade, and that actually is going to be orchestrated by Helm. What we're going to do is we're going to actually call a Helm upgrade, and then we're also going to pass a few override parameters, which essentially are operator overrides that anyone using the OpenStack Helm charts can override. And one of the things we're going to override is the image that we want deployed on this upgrade of Cinder. So on the right-hand side, what we should see start to happen is that because of our rolling upgrade parameters that all of our charts have, Kubernetes will start terminating old versions of the charts, but our rolling upgrade parameters make it quite clear that Kubernetes needs to keep at least one copy of the previous API running while it actually spawns the new containers with the new images. This is what allows us to continue to poll the Cinder API while new containers are forming. Once those containers actually enter into a ready state, which some of them already started to do, only then will Kubernetes terminate the old versions of the old containers. At this point, the Cinder service has been upgraded. It took about 45 seconds. They're all in a ready state, which means everything is looking good from a readiness probe perspective. And we should be able to rerun our script that dips inside of the Cinder containers and gets the version and see that we are now on a completely different git commit because we are using a different image of the Newton version. And we will see that this commit is in September when Newton was tagged, and it matches our commit for the Newton release. And of course, down here in the bottom screen, we see that during this whole rolling upgrade process, we have, of course, been polling the Cinder API and have not received any failed requests.